In 4.7, we're going to be looking at matrices and matrix operations. So kind of building upon what we did with systems, matrices are really good for solving a system of equations. And we're only going to kind of dabble in matrices. We're not going to go fully in depth with everything we can do with a matrices. But to get us going, we kind of need some vocabulary because this is a new thing. So this is what a matrices is here, and I've got it defined. It says the matrix is a rectangular array of numbers that's usually named by a capital letter. So you can see it's normally going to be a capital letter out here, naming the entire matrix. Each entry in the matrix is referred to as A, and then you've got the subscript I, J. I is representative of the row, J is representative of the column. We'll work with how to figure that out here in a minute. And matrices are often referred to by their dimensions, M times N, indicating M is the rows and N is the columns. So a row is a set of numbers aligned horizontally. So you can see this entire part here, this would be your row. A column is a set of numbers aligned vertically. So this entire area here is a column. And an entry is an element, coefficient, or constant in the matrix. And so like just one little entry right here, this would be an entry. When we start to talk about the size of the matrix, it is defined by the rows and the columns, so rows and then columns. So a square matrix is a matrix with dimensions n times n, meaning it has the same number of rows as columns. Or a 3 by 3 matrix like above is an example of a square matrix. We also can talk about a row matrix. It is one that just has one row of dimensions, so 1 times n. Or a column matrix, which is a matrix consisting of one column with dimensions m times 1. So let's just kind of look at that more in depth with some numbers, not just words. And so it says, given matrix A, what are the dimensions of the matrix of A? Now remember, the dimensions are m times n, where m is the row and n is the column. So you're going to look at this and say, okay, I have 1, 2, 3 rows, and I have 1, 2, 3 columns. So this would be a 3 by 3 matrix. Next, it says, what are the entries of A31 and A22? Now remember, when you're looking at this, your first number is going to be equal to your row, and your second number is going to be equal to your column. So I'm going to have to kind of move around within the matrix. So I'm going to go to row 3. So here's row 3. And this is column 1. So this piece right here would be the entry A31. Then again here, A22. So this would be the row and then the column. So I'm going to go to row 2, column 2, and this piece right here would be the entry A22. Next one says, what are the dimensions of the following matrix? So again, it's going to be row by column. And so I would say, okay, I have 1, 2, 3 rows, and I have 1, 2, 3, 4 columns. So this would be a 3 by 4 matrix. So with these matrices, we're only going to do 2 operations. We're going to do adding and subtracting, and then we're going to do some multiplying. It's not all that you can do with matrices. It's just what we're going to touch on here, right here at the end of this unit. And so part 3, let's look at adding and subtracting 2 matrices. So a little bit of background information. Given matrices A and B of like dimensions, this means they have to be exactly the same size, a 3 by 3 and a 3 by 3, a 2 by 4 and a 2 by 4. So like dimensions. Addition and subtraction of A and B will produce a matrix C or matrix D of the same dimension. So if I take A plus B and get C, then that means I'm literally going to be adding each of the same entries to get that new entry. If I'm going to do A minus B, then I'm just going to subtract each individual entry by their position. So matrix addition is commutative. A plus B and B plus A would give you the same result. Not always true with all operations. And it's also associative. So it's important to kind of know what you can and can't do with this. So I want to practice some with you, and I'm going to do a few examples here. So it says find the sum of A plus B. So I'm going to be adding these two together. So you'll notice this is a 2 by 2 and a 2 by 2. So my final answer is also going to be a 2 by 2. All of these dimensions will have to be the same. So when you go to add 2 matrices together, what you're going to do is you're just going to add the corresponding entries. So I'm going to take 4 and 5. I'm going to add them together. And notice I'm going to put them right here in that top left, that A11 entry. Then I'm going to add 1 plus 9. Again, it's in that A12 entry, so it's going to be in that A12 entry in my answer. 3 and 0, and 2 and 7. And I just want to kind of write out the addition of them so you can see where all the numbers are coming from. And then, of course, I'm going to have to add them to finish it up. And so this would be A plus B of my matrices. So you can notice when you write a matrices, you do have it contained with brackets or parentheses, and it's an array of numbers. So let's try this again. Next one says add the matrix A and the matrix B. So you can see I have a 3 by 2 and I have a 3 by 2. Because they're the same size, my answer is also going to be a 3 by 2. You'll see in the next operations why I'm emphasizing these dimensions. But again, you're just going to add up the corresponding entries. So you're going to say 2 plus 3, 1 plus 1, 1 plus negative 4, and then I'm going to do 6 and negative 2, 0 and 5, negative 3 and 3. Now I understand if I were just adding this and not teaching this to you, I'd probably just kind of add in my head as I go and write those numbers. But I specifically just want to kind of write them down here in your notes so that when you come back and look at this or you take a sleep, you go on and work on another class, you can see where these numbers kind of appeared from. So this would be my final answer of the matrices A plus B. You can see again, it's a matrices of dimensions 3 times 2. Now let's do one with subtraction. Don't forget that you're subtracting the whole way. So again, I have a 2 by 2 and a 2 by 2. So that means my answer is going to be a 2 by 2. So I'm going to say negative 2 minus 8. So negative 2 minus 8. Again, I just want to show you where the numbers are coming from. But if I were working this and I were a student, I would probably just be kind of doing the addition in my head. Other operations I can't really do in my head, but this one I probably could. So then I would have 3 minus 1 here, 0 minus 5, and 1 minus 4. So with this one, again, difference is subtraction. So same process, each entry corresponding is put together. So it gives me negative 10, negative 5, 2, and negative 3. So operations such as addition and subtraction are not a big deal. We're going to ease into multiplication. We're first going to start with multiplying a matrix by a scalar or a sum scalar multiples of matrices. So when we're looking at a scalar, the first thing we're going to do is notice that when we're multiplying by a scalar, we are going to say that everything is getting multiplied. So we're amping up the entire matrices. Scalar multiplication involves multiplying each entry in a matrix by a scalar, so just by kind of a coefficient. Scalar multiplication involves finding the product of a constant by each entry in the matrix. So if this is my matrix A and my scalar is C, C times A would just mean C times the whole matrix. And so you can see C goes into every single entry, almost just by distribution. Scalar multiplication is distributive, looky there. For the matrices A, B, and C with scalars A and B, if I'm going to do this, I could distribute the A, B into there. Or I could put A, B's together and then distribute onto the A. So let's kind of do it with numbers, make a little bit more sense. This says multiply matrix A by the scalar of 3. So that means I'm going to do 3 times A. So that means I'm going to be doing 3 times every entry into that matrices. So I'm just amping up every matrix. So that means I would do 3 times 8, 3 times 5, 3 times 1, 3 times 4. And so my final result would be 24, 15, 3, and 12. And so again, I want to show you this step in here so you have a good resource when you're looking on your notes. But again, you can see that the 3 is just going to every single entry. Let's do another one. This one says, given matrix B, find negative 2b, where b is this. So I'm going to be multiplying a negative 2 times everything in b. So I'm going to say negative 2 times every entry. So it'd be negative 2 times 4, negative 2 times 3, negative 2 times 1, negative 2 times 2. So this would result in the matrices negative 8, negative 6, negative 2, and negative 4. So again, addition, multiplication, not too bad. and then multiplying by that scalar, not too bad as well. Let's kind of put the two together, and let's do this problem down here. Find the sum of 3a plus 2b. So I am going to be adding up the a and b, but I want to do the scalars time them first. So I'm going to have to do 3 times this one first and 2 times this one. So just kind of going to go slow. First, I'm going to do 3 times all this. So I'm going to say 3 times 1 is 3. 3 times -2, -6. 3 times 0. 3 times 0. 3 times -1. 3 times 2. 3 times 4. 3 times 3. 3 times -6. So this would be my 3a matrices. I'm going to add that with my 2b matrices. So now I'm going to multiply 2 times all of these. Again, I'm just kind of skipping writing out this step here, but if you're watching and taking notes, following along, you'll kind of see where the numbers come from. 2 times -1, 2 times 2, 2 times 1, 2 times 0, 2 times -3, 2 times 2, 2 times 0, 2 times 1, 2 times -4. Now that I've done my scalar multiplication, now I can add these two matrices together just by adding corresponding entries. So 3 and -2 is 1, -6 and 4 is -2, 0 and 2 is 2, 0 and 0, -3 and -6, 2 and 4, 12 and 0, 9 and 2, -18 and -8 gives me -26. You can see with this one, everyone's steps of what you need to show to get you to the next might look a little bit different, but at minimum, you've got to have something in between. I don't expect you to go, okay, 3 times 1 and 2 times -1 and add and get the 1. Like, I want to see some kind of process in between the given problem and your given answer. 1, so I can see your process, and 2, to help you to coordinate these numbers. I don't expect you to just kind of pull 9 numbers out of thin air. But you can see summing and scalar, not too bad. Definitely a good break from what we've been doing previously. So lastly, what we want to do is we want to multiply. Now, multiplying is probably the most complex thing of this section just because it has a lot of moving pieces. So let's kind of look at it first. It says multiply matrices together. So the product of two matrices is only possible when the inner dimensions are the same, meaning that the number of columns of the first matrix is equal to the number of the rows of the second matrix. So if I want to multiply A times B, and I did one with numerics here because I think it makes more sense, you have to look at the dimensions of A and the dimensions of B, and these two numbers have to be the same. If those two numbers are not the same, then you cannot multiply them together. So for matrices A, B, and C, the following properties will hold. Matrix multiplication is associative and it is distributive. Notice it is not commutative. So A times B is not going to be the same as B times A. So when we're working through this matrices multiplication, do make sure you have some room. You're writing this down because it is a little bit more in depth with the details. So the first thing you're going to do when you're multiplying two matrices together is check their dimensions. This is a 2 by 2 and this is a 2 by 2. So since these two numbers are the same, I can multiply A times B. My final result will be a 2 by 2 matrix. Now, when I'm multiplying this matrices together, we're going to need a little bit of room here. What you're going to do is you're going to multiply row 1 by column 1 and add them together. So you'll do 1 times 5 plus 2 times 7. And that piece, all that multiplied and added, is your first entry. Then you're going to do it again. And you're going to say row by column, and that would be your next entry here. So I'm going to say 1 times 6 plus 2 times 8. So I'm multiplying the row times the column and distributing it out there and adding that up. So that's my next entry. Then to get my next one, I'm going to go to row 2. I'm going to say 3 times 4, and I'm going to multiply times 5 and 7. So I'll say 3 times 5 plus 4 times 7. And that entire number is my next entry. I'm going to do row 2 by column 2. So it would be 3 times 6 plus 4 times 8. Once I multiply and add, you can see this is going to give me 4 entries. So let's see, 1 times 5 is 5. 2 times 7 is 14. So it gives me a 19. That gives me 6 and 16, so it gives me 22. 15 and 28 gives me 43. 18 and 32 give me 50. So multiplying them is a little bit more detail. You're going to have to do row times column, multiplying the entries, and then adding them together to get your single entry. And you can see that I ended up with a 2 by 2 for an answer. So absolutely with this one, you're going to need to show some work so you can get all those numbers correctly and get them into the correct spot. Let's do another one of those. We'll do one more to go with it, and then when you do the homework, if you have any issues along the way, feel free to message me and I'll help you out. First thing you want to do is you want to check your dimensions. With addition and subtraction, it has to be exactly the same size. This is not the case. This is a 2 by 3, and this is a 3 by 2. So because these two numbers are the same, I can work this out. And so I'm going to say, okay, I'm going to do row times column. Again, I'm going to write that out for you so you see where these numbers are coming from. So I'm going to do negative 1 times 5 plus 2 times negative 4 plus 3 times 2. That's one entry. Then I'm going to do the next one, row times column. So that gives me negative 1 times negative 1 plus 2 times 0 plus 3 times 3. That's my second entry. Then I'll do this row times this column. So that would be 4 times 5 plus negative 4 times 0 plus 5 times 2. And then that's an entry. Then I'll do this row times this column. So 4 times negative 1 plus 0 times 0 plus 5 times 3. So you can see this number has to be the same, but these outside numbers are the size of your answer. So now I just need to do some arithmetic. So I get negative 5, negative 8, 6, so it gives me negative 7. You can type in this whole string here if you want in your calculator. Just make sure you do parentheses and addition correctly, and that gives you 10. This one should give you 30, and this one should give you 11. So multiplication, I would say, is probably the hardest concept within this section. But if you'll go slow, write out what you're doing, and then do your arithmetic correctly, you should be okay. Again, try the homework, see what you can do with it, and contact me sooner than later. I'll be happy to help.